Hello there, Mr. Sutton here, bringing you the Algebra 2 7-1 homework solutions on inverse variation. For the first few problems, they want us to tell whether the x and the y in the problem show direct variation, inverse variation, or neither. So for all of these, we're going to isolate y and see what kind of form we can put it in. To get y by itself in this particular problem, we're just going to multiply x by both sides. So that gives us y equals 8x. And this is in the form y equals ax, so this is a direct variation form. On this problem, y is already isolated, and we have the form of a over x, so this is inverse variation right off the bat. For this problem, y is already isolated, and we can't put it in a times x form or x divided or a divided by x form, either of those. So this is neither direct nor inverse variation. For this problem, to get y by itself, we have to divide by x, so that gives us 1 over 5x. And this is essentially a over x kind of form. You could think of this as 1/5 over x. So this is going to be inverse variation. For this problem, to see whether the x and y in the table have direct, inverse, or neither variation, we're going to set up our own little table, and we're going to check to see if x and y have a common product, a common ratio, or neither. So let me just sort it all out here. We'll start with 12 times 132, and I'll need Desmos for all of these. So 12 times 132 is going to be 1584. And then 18 times 198 comes out to 3564. Now, since we don't have a common product, even in these first two, right away we know we don't have a common product at all. So we're going to move on to the ratio test here. Let's do 132 divided by 12, gives me 11. And then 198 over 18 is 11. 253 divided by 23, also 11. And I'm feeling pretty good about this, but let's just do the rest. 319 over 29 is 11. And also 374 divided by 34, also 11. Since we have a common ratio, but not a common product, that means that we have direct variation. On this one, to see if we have direct, inverse, or neither variation, we're going to check for a common product and a common ratio. So let's do the xy first, the common product. That'll tell us whether or not we have inverse variation. So we've got 4 times 21 is 84. 6 times 14 is also 84. 8 times 10.5, let's see, 80 plus 4 is 84. 8.4 times 10 is 84. 12 times 7 is also, I know, 84. So we definitely have a common product. Let's just check the ratio just to be sure, though. So 21 divided by 4 is 5.25. 14 divided by 6, probably not the same thing, is 2.33. And we don't have to check any more of those since we already failed this one. Since we have a common product but not ratio, that means that we have inverse variation. For the next few problems, they're telling us that the variables x and y vary inversely. They want us to use the values they're giving us on each of these to write an equation relating x and y, and then use it to find y, in this case when x equals 3. All right, so we have, in general, the inverse form, y equals a over x. So plug in some things in. We've got 28 equals a over 3/4. And now to get a by itself, which I need to do to write the equation here, I'm going to multiply by 3/4. 3/4 times 28, well, let me see here. 28 divided by 4 is 7, times 3 is 21. So we have an a value of 21. So I can rewrite this then as y equals 21 over x. Now they wanted us to plug 3 in for x. So y is going to be 21 over 3, which is 7. For this one, to write an inverse equation involving this x and y, let's start with our inverse form, y equals a over x. So plug in my x and y, we've got negative 5/4 equals a over negative 4. And now to get the a value, I'm just going to multiply both sides by negative 4. Negative 5/4 times negative 4, that actually cancels that denominator of 4, and it also becomes positive. So this ends up being positive 5. Plugging that back in, we have y equals 5 over x. And then plugging in 3 for x here, that's what they want us to plug in on all these, we end up with y equals 5/3. For this one, to write our inverse equation, let's start with the inverse form. So we have y equals x over, or rather a over x. And then plugging in our x and our y, we have negative 7 equals a over 5/3. Multiplying both sides by 5/3 to get a by itself, we're going to end up with negative 35 over 3, which is a weird a value, but we'll take it. So plugging that back in, we have y equals negative 35/3 over x. And now if we plug 3 in for x like they told us to here, we can simplify that a little bit. Dividing by 3 is really the same as multiplying by 1/3. Negative 35/3 times 1/3 is going to be negative 35 over 9. So that's our final answer for y. On this problem, they're telling us that the number y of apps that can be stored on a tablet varies inversely with the average size, which is going to be the x value of an app. We have a certain tablet that can store 200 apps when the average size of an app is 28 megabytes. Okay, so based on that, they want a table showing the number of apps that will fit on a tablet when the average size of the app is 20, 25, 30, and 50 megabytes. So since they're already telling us that we have inverse variation, we can use our inverse variation formula, y equals a over x. And they told us that we could store 200 apps when the average size was 28. Let's see, so that means we have 200 for the y equals a over 28. And if I multiply both sides by 28 to get the a by itself, we end up with, let me see here, that's going to be 5,600 for the a value. So plugging that back in, our formula then is going to be y equals 5,600 over x. We're going to make a table now using this with a bunch of different x values. So we have 20, 25, 30, and 50. And I'm going to go to Desmos to run these numbers here. So to kick things off, we've got 5,600 divided by 20. And that's going to be 280. And then if we make that 25, that's going to be 224. If we make that 30, we end up with about 187-ish, 186 and some change, 186.7. And finally, if we make that 50, then we have 112 apps that we can store on the tablet. So what happens to the number of apps as the average app size increases? Well, it goes down. It decreases. Not a shocker there.